in the last video how useful learning objectives can be. And this is because they really help us aim our instruction at a target. Let me give you an analogy.
So this makes sense. After all, if we've got a set of roads, we don't just sort of get in our car and start driving around. We're not really sure where we might end up. Instead, what we do is we identify where it is we want to go. Like maybe we want to go over to our friend's house. We figure out where it is that we're at. So we see where it is that we're starting, and then we plot out a route for us to actually follow. And once we've got that route, then we can follow it and end up where we want to go. So we start out by figuring out where we're at, then where it is that we want to go, and how it is that we're going to get there, the route that we're going to follow.
So let me give you another analogy, that of engineering design. We don't build a building with random specifications. We look to see how tall we want it to be, what structural load it needs to bear, what are the constraints like the materials or the cost and the budget that we have. So what we're really doing is starting with our end goals, identifying the inputs, and then undertaking the construction. So this is really what we want to do with our learning objectives. We want to start with our goals. This is called backwards design because we're starting with the end result or where we want to go. So I talked to an education specialist to tell us a little bit more about backwards design.
My name is Bill Penuel, and I study teaching and learning in STEM fields, particularly in K-12 education. So backwards design is really a three-step process. First, you define your learning goals. Then you design an assessment of those learning goals. And third, you select or design activities that will help you to meet the learning goals. The reason it's called backwards design is that our tendency in planning instruction is to look for and find activities that we think will be fun and engaging for students. But really we have to start first with what do we want students to know and be able to do? And then we have to say, what does the assessment look like? And then finally select activities that will really help students perform well on that assessment. The game is not to have a certain number of kids fail and other kids succeed, but actually to select activities so that you think everyone should be able to do well on that assessment. And that's the heart of backwards design, and that's how you achieve alignment.
Alignment is this process of making sure that your learning objectives, your assessments, and your instruction all line up with each other.
So let's say you're designing a unit in earth science on plate tectonics. So the first thing I've got to do is define a goal, a learning goal, something I want students to know and be able to do. For me, what's really important is that students don't just think of science as a body of knowledge, but as a way of knowing, as a process of knowledge development. So my goal might be something like develop a model of the cycling of Earth material in the interior of the Earth that can help explain patterns of mountains, volcanoes, and earthquakes. And so I might then go and say, well, what does my assessment need to look like? Well, it's got to have students construct a model. Perhaps I also want them to be able to use that model to explain what the features or the patterns of Earth's surface look like in relation to what's going on into Earth's interior. And then finally, I'm going to think about, well, what are the component activities of that? Well, I need to first describe, be able to get them into the phenomenon at hand. Then I need to actually have them do some modeling. I probably need to have them make those models public and share them with others and have them critique one another's model for how well they account for evidence. So that would be how I would go about designing something around that particular learning goal over a series of multiple lessons.
It's also important to remember that your students walk in the door with existing ideas.
My name is Victoria Hand, and I teach undergraduate students and graduate students theories of learning and knowing in STEM, so science, technology, engineering, and mathematics. So research shows there's often a mismatch between what we think we're teaching and what students are learning. And often it's because we don't necessarily understand what kind of prior knowledge students are bringing to the learning environment. We don't know what kind of experiences they've had. So when we're trying to teach them some material, we don't know how that material is connecting to what they know already. And so that it may be that they're learning it in a very superficial way because it's not really meaningful to them. They can't make sense of the material. So it's really, really important to understand how my goals relate to the kinds of activities that I'm going to design in my classroom for students to really make those deep connections.
So student prior knowledge really plays a role in every part of backwards design, and it can be kind of difficult to take this into account when you're first teaching. So here's a question for you. What does backwards design begin with? Backwards design begins with determining your goal or objective. That's our first step. Now, what does backwards design end with? What's the last step? The last step in instructional design is determining what instructional techniques that you'll use. So you first determine your objectives and your assessments, and then the very last thing is how you're going to teach it. So we usually talk about backwards design as applying to a single teachable unit, so like a unit on photosynthesis or Newton's first law. But it can also apply to your lesson for that particular day, so that's smaller scale, or to the course as a whole.